Have you ever looked at a picture of the solar system and felt lied to? We've all seen them. In textbooks, on posters, in the opening credits of sci-fi movies. The sun, a big yellow circle. Mercury, Venus, Earth, Mars, all lined up neatly, like beads on a necklace, nestled comfortably together. Jupiter and Saturn are a little bigger, floating a polite distance away. It's clean, it's orderly. It's a map of a place that feels almost familiar. It is also a complete and utter fiction. That iconic image is one of the most successful and most damaging diagrams in human history. It teaches us the order of the planets, but it completely obliterates the single most important truth about our cosmic home. Its staggering, humbling, and almost incomprehensible emptiness. The true solar system isn't a crowded neighborhood. It is, for the most part, a breathtaking void. A silent black expanse so vast that within it, the planets are not neighbors, but lonely, isolated islands of rock, metal, and gas, separated by oceans of nothingness so wide that light itself takes hours to cross them. Today, we are going to correct that picture. We are going to erase the comforting lie and witness the terrifying, magnificent truth. We are going to build a scale model of the solar system in our minds, and on this journey, you will discover that everything you thought you knew about the space next door is wrong, and it all starts by shrinking the sun down to something you can hold in your hand. So let's begin our mental model. To truly grasp a scale this large, we need to bring it down to Earth. Let's imagine we have a magic shrink ray and we point it at the sun. We shrink it down to the size of a perfectly round, glowing grapefruit. A nice, standard grapefruit, about 14 centimeters or 5.5 inches in diameter. In this model, our entire star, a sphere of seething plasma that contains 99.86% of all the mass in the solar system, fits in the palm of your hand. This is our anchor. This grapefruit is the heart of everything. Now, where is the closest planet? Where is Mercury? If our sun is a grapefruit sitting on a table in New York City, where would you have to go to place the tiny speck that is Mercury? You might think just off to the side, on the edge of the table perhaps, maybe even in the next room. You would be wrong. In our grapefruit sun model, Mercury, a scorched, cratered world, is not a marble. It's smaller than a pinhead. It's a single grain of coarse sand, about 0.5 millimeter across. And to place it at the correct scale distance from our grapefruit sun, you need to walk. You need to walk 6 meters away. That's about 20 feet. Imagine placing a grapefruit on the ground, then taking 20 long paces away and placing a single tiny grain of sand on the pavement. That is the true relationship between the sun and its innermost planet. Not touching, not even close. Already the emptiness is speaking. Let's continue. Venus and Earth, the so-called twin planets of the solar system in terms of size. In our model, they are also tiny spheres. Venus is a small peppercorn, about 1.2 millimeters across. Earth is another slightly smaller peppercorn, just about 1 millimeter. Where do they go? From our grapefruit sun to place Venus, you don't just step to the side. You walk 11 meters, 36 feet away. For our own home, Earth, you have to walk 15 meters, 50 feet from the grapefruit. You are now half the length of a basketball court away from the only source of light, heat, and life in this entire model. Our beautiful, complex, life-covered world is a peppercorn, 50 feet from a grapefruit, floating in a sea of scaled-down space that is, so far, completely and utterly empty. This is the first great secret of the solar system. It is almost all space. The planets are microscopic afterthoughts, and we're just getting started. Now we come to Mars, the red planet, the subject of 1,000 dreams of colonization and discovery. In our model, Mars is not a peer of Earth. It is half the size. It is not a peppercorn, but a smaller, redder grain, a single, tiny ball bearing, or a seed from a spice jar, just 0.5 millimeters across. To place it correctly, you must leave Earth's peppercorn behind and walk another 11 meters, 36 feet. You are now 23 meters, or about 77 feet, from the central grapefruit. Look back. Can you even see it? The sun from Mars, in reality, is a bright star, but a distant, cold disk. The loneliness is setting in. But here, between the orbit of Mars and what comes next, lies a frontier, a vast, sprawling ring of cosmic rubble and failed planets, the asteroid belt. And here is where we encounter one of the greatest pop culture misconceptions. Movies show asteroid belts as dense, chaotic fields of tumbling rocks where spaceships must dodge and weave frantically to survive. It is a thrilling image. It is another lie. In our true-scale model, the asteroid belt is not a dense ring of danger. It is a monument to emptiness. If you took every single asteroid, every rock from the size of Ceres, which itself is a respectable 0.1 millimeter speck of dust in our model, down to the size of a pebble, and combined all that material, it would have less mass than our moon. Scatter that dust across a ring that stretches from 23 meters to over 43 meters, 140 feet, from our grapefruit, and what you get is nothing. You could fly a spaceship, or place our scaled-down model of one, a mote of dust smaller than a bacterium, anywhere through the asteroid belt, and the chance of it even seeing an asteroid, let alone hitting one, is effectively zero. The asteroid belt is not an obstacle course. It is a silent, empty highway, the first great desert of our solar system. Now, prepare for a shock. We have been walking tens of meters from our grapefruit sun. We have placed microscopic worlds. The sense of distance is growing, but you are not ready for what comes next. We are about to meet the king. If you are standing at our model's asteroid belt, 43 meters out, and you want to place the next planet, you cannot simply take a few steps. You must completely change your concept of distance, because the next planet is Jupiter. And in our grapefruit sun model, Jupiter is no longer a speck. It is not a grain of sand. For the first time, we encounter an object with some real size. Jupiter, the gas giant, is the size of a large marble, a beautiful striped marble about 1.4 centimeters across. Compare that to Earth's 1 millimeter peppercorn. This is the first object in our model that feels somewhat substantial. Now, where does this marble go? You must turn your back on the inner solar system, that little cluster of dust specks huddled within 43 meters of the grapefruit. And you must walk and walk. You walk past the 50-meter mark, the 75-meter mark, the 100-meter mark. You keep walking until you have covered 78 meters, 256 feet, from the central grapefruit. That's the length of an Olympic-sized swimming pool. From the sun to Jupiter in our model is the length of a pool. All that space, and the only objects in it are a grapefruit, a few motes of dust, and now a single marble floating alone at the far end. This is the second great secret. The solar system is not just empty, it is lopsided. Almost all the mass that isn't the sun is in the giants, and they rule over distances that make the inner planets look like a tiny, private club huddled around the fireplace. And around Jupiter's marble, something magical happens in our model. You can place its 4 largest moons, Io, Europa, Ganymede, and Callisto, as tiny, almost invisible specks of flour, but they orbit the marble in a space no larger than the palm of your hand. For the first time, we have a real, complex system within our system, but it is isolated, a self-contained kingdom a full pool's length away from the center. The march of the giants has begun, and it makes the emptiness grow exponentially. Let's find Saturn, the Lord of the Rings, the crown jewel of the night sky. In our model, Saturn is another marble, slightly smaller than Jupiter's, about a 1.2 centimeter marble, and its glorious rings. In true scale, they would be a paper-thin sheet of glitter extending just beyond the marble's edge, thinner in proportion than a sheet of tissue paper wrapped around a basketball. To place this beautiful ringed marble, you must walk past Jupiter. You must leave the pool's edge behind and enter a new scale of distance. From the grapefruit sun, you walk 143 meters. That is 469 feet, nearly 1.5 football fields. Picture it, a grapefruit in one end zone. You walk past the 50-yard line, past the opposite end zone, and keep going for another 50 yards. There, in the empty parking lot, you place a beautiful, tiny, ringed marble. The emptiness is now deafening. The inner planets, Mercury, Venus, Earth, Mars, are now an invisible cluster of dust. Lost in the glare of the grapefruit, you can barely see back at the stadium. The distance between Jupiter's marble and Saturn's marble is greater than the entire span of the inner solar system up to Jupiter. And we are not even halfway to the edge. Next, Uranus, a pale blue-green marble just half a centimeter across. To place it, you embark on another epic trek. You walk 287 meters from the sun. That's 942 feet, over 3 football fields laid end to end. From Saturn to Uranus is another gap wider than the distance from the sun to Saturn. Then Neptune, the final giant, another icy blue marble, slightly smaller than Uranus. Its home is 450 meters, almost half a kilometer, a quarter of a mile, from our central grapefruit. You have walked for minutes to place it. The grapefruit sun is now just a bright dot, the brightest star in a black sky. The inner planets are forgotten memories. Out here, the silence is absolute. The cold is profound. And here we must address another silent lie of those textbook diagrams. They show all the planets orbiting on a flat, tidy sheet, like cars on a racetrack. This is not true. The planets do orbit in roughly the same plane, called the ecliptic, but roughly is the key word. Their orbits are tilted relative to each other. Mercury's orbit is tilted by 7 degrees, Venus by 3.4. Earth, our reference, is at 0. Even majestic Saturn is tilted in its orbit by 2.5 degrees. What does this mean in our mental model? It means that as these specks and marbles journey around the grapefruit, they don't move on a perfect glass tabletop. They move on slightly warped sheets of glass, stacked within a few degrees of each other. They bob slightly above and below the central plane. The solar system is not a two-dimensional disk. It is a three-dimensional volume, a squashed sphere of influence, with everything moving within a thin but measurable layer. This volume, this vast squashed bubble centered on our grapefruit, is where the classical solar system lives, and we have filled it with almost nothing. But we are not done. Not even close. You think Neptune is the edge? You think that quarter-mile walk from the grapefruit marks the end of our home system? My friend, we have been living in the attic and pretending it is the whole house. We have not even stepped outside, because beyond the orbit of Neptune's blue marble, the true staggering scale of our solar system reveals itself in a way that will crush your sense of place. Welcome to the Kuiper Belt. This is a vast, donut-shaped field of icy worlds, of which Pluto is the most famous member. In our model, Pluto is not a planet, but that doesn't make it less fascinating. It is a microscopic speck of dust, smaller than our model's Mercury grain. And its distance. To place Pluto in its average orbit, you must take our grapefruit and you must walk 590 meters. That is over 1/3 of a mile, 6 football fields. You have left the city block behind. You are in a different neighborhood entirely. And the Kuiper Belt itself stretches from Neptune's orbit at 450 meters out to about 750 meters, nearly half a mile, from our grapefruit. This region makes the asteroid belt look as dense as a brick wall. It is a sparse scattering of frozen primordial relics. Yet within it, we find worlds like Eris, which triggered the great planet debate, and Haumea, the spinning football-shaped world. All of them in our model are invisible motes of dust scattered across a half-mile wide empty lot. But even this, even the half-mile mark, is just the front porch. We must now make a choice. We can either continue our walk, or we must switch vehicles, because we are approaching the domain where the solar system's last gravitational whispers are felt. This is the realm of the Oort Cloud. The Oort Cloud is a theoretical spherical shell of icy planetesimals that surrounds the sun like a distant, thick fog. It is the source of long-period comets that occasionally dive into the inner solar system, taking tens of thousands of years to complete a single orbit. Where does it begin? In our grapefruit sun model, the inner edge of the Oort Cloud is about 1,000 meters, 1 full kilometer or 0.6 miles from our grapefruit. You have walked for 15 minutes to get here. The grapefruit is now just a particularly shiny point of light, indistinguishable from a star. But the Oort Cloud doesn't stop there. Its outer edge is where the sun's gravitational influence is finally overcome by the gentle tidal forces of the galaxy itself. That boundary is the true edge of the solar system. Are you ready for the number? In our model with our grapefruit sun, the outer edge of the Oort Cloud, the true frontier of our solar system, lies 50,000 meters away, 50 kilometers, 31 miles. Let that settle. If our sun is a grapefruit in downtown Manhattan, the orbit of Pluto, the old edge of the solar system, is in a nearby borough like Queens or Brooklyn. But the true edge of the solar system, the Oort Cloud, extends to the city of New Haven, Connecticut, or to the city of Trenton, New Jersey. Everything we hold dear, every planet, every moon, every asteroid we've ever visited, every photo we've ever taken, exist within a microscopic, invisible dot right next to the grapefruit. The rest, for 31 miles in every direction, is a near-perfect vacuum, populated by perhaps a few trillion frozen mountains tens of kilometers apart, drifting in the eternal dark. This is the third and ultimate secret. Our solar system is a gigantic, almost empty sphere. The planetary zone is a tiny, dusty freckle at its very center. Now, let's bring this home. Let's talk about our place in this void and the monumental effort it takes to cross it. We have been using a grapefruit. Let's shift scales one last time to a more famous model, the 1 mile solar system. In this model, the sun is scaled to be a sphere 1 meter in diameter, a large exercise ball, placed at one end of a mile-long track. In this model, Mercury is a tiny bead, 4 meters, 13 feet from the ball. Earth is a small pea, 26 meters, 85 feet away, the length of a tennis court. Jupiter is a marble the size of a large grape, 140 meters, the block and a half away. Saturn, a smaller marble, is 255 meters, over 2 blocks away. Neptune, another pea, is at the 3/4 mile mark, and the nearest star, Proxima Centauri. In this same model, where our solar system fits in 1 mile, the next exercise ball sun is 4,400 miles away. It would be in Berlin if our model started in New York. This is the interstellar scale. It is the true context. Now think of our machines. The Voyager 1 probe, the farthest human-made object from Earth. Launched in 1977, it has been traveling at over 60,000 kilometers per hour for over 45 years. In our grapefruit model, where Neptune is a 1/4 mile away, Voyager 1 has only just, in the last few years, left the area of the grapefruit's immediate porchlight. It has entered the empty desert between here and the Oort Cloud. It will not reach the inner edge of that cloud for another 300 years, and it will take tens of thousands of years to pass through it and into true interstellar space. We are trapped, for all practical purposes, in our tiny, dusty freckle. The voids are too great. The distances are a prison of cosmic proportions. So, let's return to that textbook image we started with. That tidy line of touching planets. See it for what it is now. Not a map, but a cartoon. A helpful, but deeply misleading, lie of convenience. The truth is so much grander, so much more frightening, and so much more beautiful. The true scale of our solar system teaches us two profound, humbling lessons. First, we are alone. The planets are not neighbors. They are distant, lonely outposts in a sea of black. If two planets were grains of sand, they would be separated by miles of empty beach. This solitude is the fundamental condition of our existence in the cosmos. But second, and most importantly, we are together. On that single blue peppercorn, 50 feet from a grapefruit, huddled in the immense, silent dark, is everything we have ever known. Every mountain, every ocean, every forest, every city, every laugh, every tear, every love story, every war, every work of art, every human who has ever lived and dreamed and looked up at the night sky. All of it exists on that one fragile, life-covered speck. The solar system scale does not diminish us. It elevates our home to a miracle. It is the ultimate lesson in perspective. We live on a rare, precious, and isolated jewel in a void of staggering magnitude. The next time you see that simple diagram, remember the emptiness. Remember the walk. Remember the grapefruit, the peppercorn, and the 31 miles of silence. We are smaller than we ever imagined, and our world is more precious than we ever dreamed. Look up at the sky tonight, see the vast black canvas, and know that within it, you are standing on the only speck that matters, adrift in the most magnificent void imaginable.